Hello again everyone, welcome back to ptet.chemistry channel. So in this new topic, we are going to cover experimental techniques and chemical analysis. So this is not necessarily the most difficult topic of all, but it seems to be the most assessed, meaning to say Cambridge really likes to ask questions involving experimental techniques and chemical analysis because they usually come out as part of paper 3 practical studies as well as paper 4 alternative to practical. So these are becoming more and more common as compared to coming out in theory paper 1 and paper 2, but that's not to say that they will not come out in paper 1 and paper 2 as well, because whatever that's stated in the syllabus as this learning objective do appear in the syllabus, it means that they could ask you in paper 1 and paper 2 as well. So even though these paper 1, 2, 3, and 4 are for the 5070, the Cambridge International O Level curriculum, this is equally similar to the IGCSE Chemistry Extended curriculum. So whichever 14 to 16 years old curriculum you're doing, the contents within will have been suitable as well. So let's get started. So ideally speaking, I shouldn't even be teaching this topic without being in the lab and showing actual apparatus and stuff, but at this very moment in time, due to the current school closure as a result of the ongoing pandemic, so we have to do and recall our experience from what we have done a few months ago, a few weeks ago, as well as your lower secondary experience when you had done science previously. So naming appropriate apparatus. So you should be able to name apparatus. We are going to measure time. So we need something called stopwatch or stop clock. So the important thing about stopwatch rather than using the hand clock on the wall is because these are more precise. Precise meaning more accurate. As they can measure up to like the nearest seconds and stuff. And yeah, you will have pressed one of these before. Okay, so temperature. So to measure temperature, we need these things called thermometer. So a thermometer come in various disguises, but the most common thermometer used in the lab. So in the laboratory, our thermometer is the one that ranges from 10 degrees Celsius to 110 degrees Celsius. Yeah, I mean that is typically the range of the temperature that our thermometer that are available in the normal school laboratory measures up to. As for the next one is to do with masses. So mass is to do with how heavy. So we are going to be talking about balances. So there is mass. You can have electronic balance. You can have the really traditional scale. So the traditional scale are the one you usually have at the market when you go and buy fish or vegetables. We also have the digital balance. Those would have been the one that you would have used when you were doing gravimetric analysis, when you were heating up some stuff, some solid, to remove the water of crystallization in the crucible. So those were gravimetric analysis kind of experiments, and they were dealing with masses. Okay. As for the rest of these, we're also going to be collecting volume. So this volume here can refer to volume of gas. By then we are talking about gas syringes, which are used to collect gas. So we are collecting gas in a gas syringe. Whereas burette, volumetric pipette, and measuring cylinders, these are, so D, E, and F, they are what we call volumetric analysis. So towards the end of the last topic on mole calculations, we talk about the mole in solutions. We talk about all of these as you have already done titrations after you did the mole calculations topic. So they're all related as well. So that's to do with volume of solutions. Just remember that solutions are mixtures, so they are dissolved in water, so they are not pure. But when you have gas, they are pure substances. Unless you have a mixture of gases, then it's a mixture, and they are not pure, such as the air that we're breathing in is a mixture of predominantly, majority of it is nitrogen, but we also have oxygen as well as various other gases. So all of these are apparatus which you should be able to spell properly, especially for the burette, pipette, and as you know, you can use measuring cylinder as well, but they are not the most accurate at measuring volume. Typically, we use pipette and burette just in the titration experiments, okay? Anyway, So each of these have advantages and disadvantages because as with any experiments, there are pros and cons. So pros refer to advantages, cons refer to the bad side, the downside, which are the disadvantages or the weaknesses of each method as well as each apparatus. These are suggestive questions. So suggestive would mean that you need to think a little bit harder, and to be able to think, you need to usually recall back when you use this apparatus, what was the problem. So a lot of students, they try to think of experimental methods just by reading, but in actuality, it's an experimental method because you are expected to have learned from having done similar experiments and learning from what works and what didn't work. Finally, 12.1.3, so this last bit of the learning objective is just a series of definitions. As with anything in the previous topic, you know that definitions are very, very important because they are basically going to be terms that you'll be using a lot. So if you don't know the definitions, you'll be describing stuff incorrectly. So make sure you know what is going on. Solvent is the substance that dissolves a solute. Solute is the substance that is dissolved in a solvent, whereas a solution is a mixture when you have one or more substance dissolved in a solvent. Okay, so even when you have one substance dissolved in a solvent, it's called a mixture because you have one substance and you have one solvent. So it's a solution, it's a mixture. So it could be a mixture of one or more solute in a solvent. Give you an example. For example, NaCl solid. This is your table salt. When you add it with H2O liquid, what you're going to get is NaCl aqueous, which is the salt dissolved in water. So what you're going to get is salt dissolved in water. And what do you get? You get a salt solution. So the salt solution is a mixture of NaCl in water, where the Na plus and Cl minus ions are free to move around, whereas in the solid state, the Na plus and the Cl minus were in a giant ionic lattice. Giant ionic lattice consists of repeated array of the oppositely charged ions. They are oppositely charged as they're attracted by ionic bond. They are giant ionic lattice. Lattice only exists for giant structure because they are repeated in three-dimensional, not just as simple as what I've drawn here. But obviously the ions are tightly packed. That was part of the states of matter, the properties of solid. The ions are tightly packed in a solid state. They are not free to move around. They cannot conduct electricity at all as a solid state, whereas they can't in the aqueous state because the ions become free to move around because they're then surrounded by water molecules. So the salt dissolves in water. So the salt is what you would call a solute because the solute dissolves in the water. The water is the solvent. And what you get is a salt solution. When something is dissolved in water, we just call it in aqueous state. Aqueous or AQ bracket refer to something which is soluble. So that means it is it is dissolved in water and therefore giving a salt solution and NaCl aqueous. I'll give you another example. So H2SO4 is a molecule. It's a simple covalent molecule. Okay, so what actually happened is it's a liquid at room temperature and pressure because simple covalent molecules has low boiling point and melting point. As we know that we just need to break the weak intermolecular forces between the molecules as part of the simple molecular structures. That's what we break when we want to melt or boil simple covalent molecule. When I add that with water, so they form a mixture, and that is what gives us H2SO4 aqueous. All dilute acids, in fact all acids, are going to be aqueous in solution because all the acid that you get consists of that pure substance dissolved in water, giving you aqueous acid. All right, just to reiterate my point, just to focus on my point, I want to emphasize that all acids are solutions. All acids are aqueous solutions. There's no acid, there's a pure substance. All acids are dissolved in water to give you the aqueous solution of the acid, and this is actually part of the definition of acid, which we will cover in a different topic. So what can we say here? This is the solute, the pure substance, dissolved in the solvent in order to give us the solution, which is the aqueous solution. So I hope that brings home, that drive home the message that what is a solute, the substance that dissolve in the solvent. What is a solvent? The substance that is used to dissolve the solute. And then what is a solution, which is obtained when the solute dissolve in a solvent. So all of these are definitions, and all these definitions are outlined here again, so that you don't just memorize it, but you think about it in terms of the underlying chemistry. So in terms of saturated solutions, saturated. So when we say that our brain is saturated, our memory is saturated. Saturated means full. It means full. When your memory is saturated, you can't fit any more new memory because your memory is full. So saturated solution, we're trying to dissolve something, the solute in the solution. So it's the maximum concentration of a solute because it's the maximum amount of solute that can dissolve in the solvent at a particular temperature. When you make a syrup solution, there's a certain amount of sugar you can dissolve in the water to give you the sugar solution, which is the syrup. However, when you heat it up, then more and more of the sugar can dissolve. That's because solubility means how much dissolve in the volume. So solubility in a sense has the same unit as concentration. How many mole dissolve in the dm cube, or how many gram dissolve in the dm cube. So solubility has the same unit as concentration, whether it's molar concentration, mole per dm cube, or it's mass concentration, gram per dm cube. As you know from the previous topic, mole equal to mass over mr. And of course from there you can get the other formula, which is mole divided by dm cube is equal to gram over dm cube divided by gram per mole. This is a very, very common calculation question. They like to ask in a titration question as part of practical chemistry, and they like to ask this in theory paper, in paper 4, and I cannot say that they will not ask you in paper 1 or paper 2, because they can and they will, I just don't know when. Okay. Anyway, saturated solutions. So there's the maximum amount of the solute that can dissolve in a solvent, very importantly at a specified temperature, because as temperature changes, concentrations of the solute dissolve in a solvent, meaning to say the solubility can change as temperature changes. There is something that you have learned in lower secondary. Last but not least, we have residue. So residue and filtrate, this is to do with the idea of separation technique. So we will come across separation techniques as part of experimental techniques required in this particular topic. Alright, so residue is whatever is left behind. So remains mean whatever is left behind, that is left behind after you do evaporation, filtration, or any other similar process. Evaporation is when you just let the solvent evaporate, you just let the solvent vaporize away or turn into a gas. All right. Filtration, well, filtration, the verb itself is filter. So filter means you remove the insoluble stuff from the soluble stuff from the solution. Filtrate, so if you do filtration, so for example, we have dirty water, muddy water, and we want to remove the mud, we'll pass it through a filter, and the filtrate is the liquid that passes through. So if I have filtration apparatus, as you know, I can have a filter funnel, but filter funnel has got holes in between, so I need to have a filter paper. So this is the filter paper as my filter, and then whatever is left behind, I have some solid left behind. This solid that's left behind is what you call residue. Residue means whatever is left behind. And then I have some stuff that pass through. So I have the stuff that pass through, which will be the solution. That's called the filtrate, which is basically the liquid or the solution that pass through a filter. This is not necessarily pure, because you could have some other stuff which are soluble in the water as well. So for example, if you have sand and you have salt, such as NaCl, so sand is insoluble in water, does not dissolve in water. So insoluble is does not dissolve, whereas salt obviously dissolve because it is soluble, so it dissolves in water. So we'll get a salt solution, and we'll come across different techniques later on to try and separate out the salt from the water, by various other techniques after that. Okay, so that's it really for this first part of the first part of the lesson. So I hope that it's just driving home the message, the importance of all these terminologies, as well as the apparatus that you need to have a good knowledge of. If there's any of these apparatus you have never seen before, which I don't think you would never have seen them before because you have done lower secondary sciences, and all of these are quantities that we have done in physics as well. So except for this burette and pipette, which you might not have seen in physics, but now that you have done the titration experiments, so you can recap and review your experience as well as your your titration worksheet from the previous topic, and you can think about all those practicals you have done previously. And all of these are just definitions of substances that will come across in the next subtopic on separation techniques. So I'll leave it there for this lecture tutorial, and we'll continue more in the next lecture tutorial. Thank you for watching.